Hi students, welcome to physics class. In this video we will discuss about variation of g. G is called as acceleration due to gravity with latitude. First of all, we have to know what is latitude. Latitude is the angular distance north or south of Earth's equator on the globe. Let us consider an equatorial line, and here a particle is situated. The angle made by the radius with the equator is called as latitude. Latitude can be taken with respect to north or south. The latitude is measured in degrees. At the equator, latitude is 0 degrees. At the poles, the latitude is 90 degrees. Let us consider a particle on the globe or Earth. Here, r is the radius of the Earth, phi is the latitude. Let us consider a particle is situated at the point P. At this point, this particle experiences, or the object experiences, two forces. First one is the centrifugal force Fc, and the second one is gravitational force Fg. So we can clearly say that forces acting on the object at P are, first one, gravitational force, which is acting towards the Earth's center along the radius. It is denoted by Fg. And the second one is centrifugal force, which is acting away from the object or the body, which is denoted by Fc. At point P, the particle is rotating along the globe with radius r, and there exists an equal and opposite centripetal and centrifugal forces whose magnitudes are equal and they act in different directions. From the figure, in triangle OO'P, by applying cos phi, we know that cos phi is equal to adjacent side by hypotenuse. Here adjacent side is r and the hypotenuse is capital R. So small r is equal to capital R into cos phi. Now resolve the centrifugal force Fc, which is equal to mr omega square into 2 orthogonal components. Then we get first one mr omega square cos phi, second one mr omega square sin phi. Now observe the figure. Fc is equal to mr omega square is resolved into two components. First one is mr omega square cos phi. Here the opposite angles are equal, and another component is mr omega square sin phi. So finally Fg and mr omega square cos phi are the two forces acting on the particle at the point P. So we can write the net force, which is equal to mg minus mr omega square cos phi. Here mg is greater than mr omega square cos phi. R is equal to r cos phi. By substituting, we get mg minus m into r cos phi into omega square cos phi. In the next step, we have mg minus m into r into omega square cos square phi, which is equal to the net force. We can write the net force by taking m as common, and the net force is written as mg suffix phi. M gets cancelled, and finally we arrived at the acceleration due to gravity at the latitude. Now we know at equator latitude is equal to 0 degrees. By substituting in the above expression we get g at equator is equal to g minus r omega square cos square 0, which is equal to g minus r omega square into 1 whole square, which is equal to g minus r omega square. Here cos 0 is 1. At poles the latitude is 90 degrees. By substituting we get g at pole is equal to g minus r omega square cos square 90 degrees, which is equal to g minus r omega square into 0 square, because cos 90 is 0, which is equal to g. At equator the g value is less, and at pole the g value is very high or more. So finally we know that at equator the g value is less, and at pole the g value is more. This is earth equator and this is pole. As we move from equator to pole, the acceleration due to gravity g value will increases.